Good afternoon, and thank you all for joining our first webinar of 2025 on Creo Advanced Assembly Extension, also known as AAX. I'm Maddie, the marketing assistant here at PLM Central, and just to give you a rough agenda of today, we're going to be diving into the features and benefits of AAX and how obviously it can help elevate your company and business. We'll also touch on pricing, followed by a Q&A session towards the end. I'm not going to be speaking today, it'll be Andy. He's our senior application consultant, and I'm going to pass him over to you.
Hi, hello everyone. Yeah, I'm Andrew Lawn. What we're going to do, it's a bit of an overview. It's quite a complex subject, is advanced assembly, but this is an overview of the functionality and why you're actually going to benefit from advanced assembly, or AAX as it's known. So what Maddie said, and as we've just discussed, there is a data Uno bundle that we will discuss pricing at the end. But within that, you get the essentials, core functionality, which is probably what you've already got. But then it also includes the AAX extension and the prismatic multi-surface milling. So excuse me. So why do you want the Creo AAX extension? Basically, Creo AAX takes the complexity out of designing, managing, and sharing large assemblies. So the first thing is the ability to support concurrent engineering through the effective sharing of geometry features, published geometry, and other CAD data. And the thing after that is the ability to improve assembly performance using enhanced top-down design process to promote faster, easier design. Thirdly is the ability to capture design intent and drive the creation of assembly designs using skeleton models. Skeleton models is quite a key thing of AAX. Fourth is the ability to simplify assembly customization by managing and sharing critical engineering data for efficient creation of design variants. And finally, what you've also got is the ability to develop assembly drawings from one main assembly, and you can create process plans, parametric process plans, and this can speed up the creation of detailed works instructions and service manuals. I will go into detail. So what do you get in the AAX package? So you get the ability to do skeleton models. It also includes performance enhancements for for very large assemblies that might take 2 or 3 minutes to open. So that includes shrink wrap, default envelope, and simplified representation. You also get the ability to program in assembly level, and it also includes notebook, which can be used to drive parameters for the pro program. We have data sharing features, which are a really useful part of AAX. So you can use copy geometry. Published geometry is used with skeleton models, and there's also the inheritance feature. And basically an inheritance feature, for example, if you've got a casting, you could use that, inherit that casting, and then create a machined version of that component. And if you modify the casting, then the inheritance feature will update, and it will update your machining part. Also includes some assembly tools to make it a little bit more efficient. So there's unrelated replace for swapping out parts, interchange assemblies, create unplaced included components, reference scope control. There's UDF library at the assembly level, and you've got the external merge and cutouts. And as I said earlier, you've got the assembly process planning module as well. So concurrent engineering and top-down design. And so we need to define the assembly structure using top-down design tool. So Creo AAX provides the capability needed to define the assembly framework using skeleton models in order to define the top-down design assembly structure. So within that, you're going to capture the design intent in your skeleton model. It is possible to do motion skeletons as well to support mechanism design. The advantage of a motion skeleton is you can swap parts out in and out, and it won't break your mechanism. You can establish and enforce assembly best practices. So you publish geometry and share reference process, and collaborate and implement top-down design changes. I will try and explain that later. The reference viewer makes it easier to identify dependencies and understand change propagation by visualizing the parent-child relationships. You can sort of see it here that this is a reference viewer. So skeleton models. What is a skeleton model? Basically, it's a collection of, it can be surfaces, curves, datums, relations, layers, views, notes. Essentially, it's just like a normal part, but you're making it into a skeleton. And what you can do is define design intent and manage component dependencies. So basically, all the components you create will reference the skeleton rather than, say, other components. And by doing this, you eliminate dependencies to the external geometry. Skeleton models, as I say, they have special properties, so they're excluded from mass property calculations, they're excluded from bill of materials, they're always the first component in the assembly, an example here, and the default name is to have SKEL in the name, obviously short for skeleton. In a very large assembly, like you can see on the top right, you can actually you can have multiple skeleton models to try and simplify the assembly design. So just to try and give a little bit of a flavor of a skeleton model. So on the top left, I've got a simple engine design, and within that, it's got datum planes and geometry and surfaces. And what I can do is publish the data for the conrod. So we've got like these two surfaces. So this is published, and then using copy geometry, I can then copy that geometry into my new conrod part, and then I can create my conrod using that copied geometry. And so the conrod references the skeleton. So for example, if I then modify the conrod, you have to do it at the skeleton level. So modify it from say 25 to 35. The copy geometry updates, and basically it gives me a longer conrod. So it's actually controlled by the skeleton at the top level, and it's fed down to the lower level. And that can be, so that geometry can then feed to multiple components for the other design engineers that are working on the assembly. So here we have some slightly more complicated examples, but the same approach can be used for much larger assemblies, capturing the design intent. In complicated examples, you can have multiple skeletons, like I said, and this can simplify the collaboration with multiple designers. So to create a skeleton, you may not have a good understanding of all the detailed components, but generally you do have a good understanding of the layout, things like locations, keep out areas, that kind of thing. And then this can be used to, as I say, collaborate with all your engineers sharing that data. So also you get shrink wrap options, and within shrink wrap, this is basically, if you've got a complex assembly, a shrink wrap will give you a lightweight version that comes in three flavors. You've got the surface subset, which you can see on the top here, which is just basically a collection of surfaces. You've got the faceted solid, which is it's basically a placeholder because you don't really get that much detail. And then you've got merged solid, which is it gives you the most accurate shrink wrap, and that can be, that can be used, but it's still a very light version of your assembly or component. So as I say, it only uses surfaces and datums. You get much smaller file size, and if you're actually going to do a shrink wrap part and send it to a supplier or a customer, it protects your intellectual property because there's no feature information. So default envelope rep, this again is something that's available in AAX. This is a capability to swap out simplified version i.e. the envelope version of a sub-assembly, for the full version, obviously that gives you the performance improvements. You can simply click on the assembly, on the sub-assembly at the base of this steering tower, and you can say you want to substitute the representation, substitute the master out for what's called an envelope rep, and you build this on the fly, and it's essentially a shrink wrap feature that you can swap in and out of the full assembly. And again, it's all about performance improvements. So assembly automation. In this example, I've got two layouts there of the trailer, and I can change the number of stalls, I can change the number of doors, I can change the length, I can change the width, and basically that layout will then drive these two assemblies using Pro Program. You drive these two assemblies. So for example, I've got the long trailer there with 3 wheels, and then I've got the shorter trailer with just the 2 wheels and a door, and this is all driven by the notebook. So that's an example of assembly. So copy geometry. This is an area that is widely used. So again, it's all about performance management. So you basically copy what you need. So in this example, I've just copied the geometry that I need from this motor. For example, I perhaps just want the 4 holes for the part that I'm creating. So using copy geometry, I can then use that to then design, and I don't need the whole assembly. So again, that gives you the performance improvements. That's what it looks like in your model. That's what it looks like in your model tree, and it just appears there in the ribbon. So replacing unrelated component. So this allows for a component to be replaced with a different unique part or assembly, and it also allows for reference pairing. So what you get, if you've got the 2 parts, I pick one, a reference on this part, a reference on this part, and this is what you can see with the reference pairing. So I'm basically like for like references, and using this tool, I can swap in and out these components. If I keep the link, I can actually switch back very easily. You might not want to keep the link because this is a this is a connection that you know, if you don't copy all the parts, you might have an issue. But yeah, it's a very useful tool for swapping in and out parts. Interchange assemblies. This works in a very similar way to unrelated component. It's not used as much now. We have the unrelated component, but basically you're going to use it where you've got multiple parts and assemblies that you want to like try different iterations in your assembly, and there's 3 here, but you can have multiple, 5, 6. You can have as many as you need, and basically just by clicking on the component, you just swap them in and out very easily. So I mentioned assembly process planning. So this is so I've got the large assembly there. You can see the fan there, and from that assembly, I can then easily define a sequence of events for the assembly. And what you can do is step-by-step drawings. So for example here, that's the initial assembly of the blade, that's assembling the rest of the blades, and that's assembling a flange. And this is all just by taking step-by-step stages of the large assembly. This is a simple example, and you can completely document the process. You can have a bill of materials at each step, and you can color code it as well to make it visually easy for the guy on the shop floor to use these process plans. Pro Program, I touched on it. If you've actually done some Pro Program in normal part mode, it's very similar, but it's a tool that uses logic to manipulate the model based on user input. So Assembly Pro Program can also regenerate the parts that are in the assembly. It can be used to do that. And also you can interchange parts, or, you know, swap parts in and out using Pro Program. So finally, just I don't know if you've used UDFs in part mode, but the user defined feature in assembly mode allows you, so it's basically you know, in this example here, you know, you got a few features, and by creating it as a UDF, you can very quickly add that to your design. but in assembly mode, it also lets you do multiple components, and so it lets you place things very, very quickly. And yeah, and that's it. Now I'll pass you back to Maddie on the pricing.
I'm going to quickly skim, only because I'm conscious of time. So currently, we have an offer going on called the DAO bundle. So Creo Advanced Assembly Extension alone costs, well, the floating costs about 15.5K. But with the offer, it's 5.6. The bundle includes T1, which I'm guessing a lot of the businesses do have T1. As long as this, alongside one more, which is Creo Prismatics and multi-surfacing milling extension, which is part of T2, which Andy did mention briefly in the beginning. This offer is currently going on. Both the floating and the locked prices are much better, I would say. But yeah, I mean, it's really a fraction of the price, a third, if I say. But that is the bundle that is currently going on. So if you are interested, obviously you can get in contact with Andy, or obviously any of the team members. I'm just going to briefly, it's very brief because I am conscious of the time. But if there are any questions, you're more than welcome to pop it in the chat or unmute your mic, or you can contact Andy himself. But that wraps up the webinar of Creo Advanced Assembly Extension. I hope you enjoyed, and I hope there was something that you can take back and obviously speak to your businesses about. But if there are any questions, we're more than happy to take it on now.
Thanks, everyone.